Good. Just to begin with, I want to give you a brief overview of the construction sector, because whether we talk about sustainability or any kind of endeavor that we may wish to achieve together in a sector, it all comes down to people. And I'll present you with some facts and figures in Europe so as to understand the overall situation in Europe. And I'm actually curious, because I'm hoping for a small talk here, a small debate, whether in other parts of the world you are confronted with similar issues. So what happens in Europe right now in the construction sector? We face a strong tendency of population aging. In many countries, some of them you can see on my slide here, but it's a tendency all over Europe. And this is probably something that all the world is familiar with. Also, we have a declared mobility of 2 to 4.5 million people annually, intra and extra community. So some move around within the EU, some leave the EU. Some of the countries in the construction sector are expected to experience a decrease in terms of employment, although the needs in the construction sector are actually increasing. The sum of persons employed in the construction sector in Germany, UK, France, Italy, and Spain account for 61.5% of the total workforce of the EU construction sector. So you can see there is a disproportionate number of people that are employed in 5 countries of the 26 now. And by 2030, we expect the employment in the construction sector to increase by 4.3%. However, in some of the countries, the ones that already employ lesser people, we expect a tendency to see a decrease in the employment in the construction sector. That is due to the mobility of the population and to the aging of the population. So there are some social phenomena that are really influencing, having a strong influence on how the construction sector shapes itself throughout the next decade. The upskilling of the workers in the construction sector is a perpetual concern in Europe. And I do wonder if this is the case in the US or in other parts of the world as well. But in Europe, this is a very serious issue, because we witness a serious crisis of human resource in the sector. So before we talk about sustainability, about the Bauhaus initiative, and about all this transformation that we want to be seen in how we build and how we treat the built environment, we have to seriously treat this very important crisis that we're going through, which is the human resource crisis. There's lack of workers, and there's also lack of competence. So there are some drivers for upskilling, which are actually the same drivers that we see for this tendency to tackle the sustainability issues and the energy efficiency issues in the construction sector. So there's the same drivers towards progress, let's say, and this is the need to look into resource efficiency in all the aspects, all resources. The digital decade in the EU, because we have a policy in the EU for this decade, which has been declared a digital decade, and I'll walk you through some of the figures that the EU tries to achieve by 2030 in terms of digitalization. We also have the Green Deal, that is an important policy in Europe right now, the renovation wave and the Bauhaus initiative that you're going to hear about next in Mr. Liano's talk. We expect, according to an evaluation of the Build Up Skill Initiative, 3 to 4 million blue-collar workers to need upskilling in the field of energy efficiency alone. But energy efficiency is one of the pillars of sustainability, and the other one is the digitalization. And in terms of digitalization, I'm going to show you some of the figures that I promised I would. In terms of digitalization, the European Union wants to achieve a level of 80% of the population with basic digital skills by 2030. 75 companies using cloud, AI, or big data, 90% companies reaching the basic level of digital intensity, and 100% digital key public services. This is our aim for 2030. But however, we are very far from these aims. And I'm going to show you later how we stand in terms of digitalization in Europe. But in order to achieve this, we are confronting with these obstacles. In the construction sector, we have some situational barriers related to the aging population that I already talked about, and the slow digital transformation of the sector, because it's a very conservative sector. And if there are engineers in the construction sector, not architects, but engineers in the construction sector, you will probably agree with me that companies in this sector are extremely conservative, especially when it comes to digitalization. Also, there are structural barriers related to the fragmentation of the market and of the construction value chains. There's also an element of seasonality in the construction sector, also a lack of public support and limited availability of training. And last but not least, there's a very poor image associated with low job security, and also with tough working conditions and health and safety concerns. This is the case in Europe, and in particular in Central Eastern Europe, if you want. But it's an issue that the overall Europe is confronted with. This is why we lose students every year. So less and less people are interested in uptaking studies in the construction sector. We have less and less applications for faculties and engineering faculties in the construction sector. So these are very serious concerns which we need to tackle before we get to the philosophy of how we're going to deal with our built environment. This is how the digitalization looks in Europe right now. You see, there's half of Europe that is more advanced in terms of digitalization. There's half of Europe that is lagging behind, and some of the countries which are confronted with aging population and low skill level are also the countries that are more conservative in terms of digital transformation. These the table that you see right here, the graph that you see, reflects the overall digitalization in Europe in all industries. However, the construction sector is contributing negatively to these indicators, because it's the second least digitalized sector in Europe. It's only agriculture that is doing worse than construction in terms of digitalization. So you see where we stand, and why we have considered to build this innovation cluster that I'm running, which is dedicated for the next 5 years. It's dedicating all its efforts entirely to the digital transformation of the construction sector. What we hope to achieve is a cultural shift towards innovation within the sector in Romania, but not only, because we're also working with other countries in Southeastern Europe. We're rethinking business models in the sector. We try to increase agility and adaptability, mainly through digitalization. And we are highly interested in the adoption of building information modeling to a larger scale. It's almost absent in Romania. We only have architects that are using some architectural companies that are using the building information modeling. Very few constructors, builders that are considering using building information modeling. This is why we cannot integrate, and we don't have by now a full project that has been done entirely through the whole life cycle of the building in using building information modeling. Of course, we also focus on upskilling, because like I said, this is a foundational problem. This is a structural problem that if we don't tackle, we can't really move further with the other aspects that we're looking forward to. Now, some major challenges, I already talked a little bit about them. It's the construction sector resistance to change, but also the pandemic. The pandemic also helped a little bit the digitalization, because people started to use, they had to, so they started to be a little bit more permeable to the idea of adopting some digital tools. But it hasn't been a real revolution, just a slight openness of the managers and entrepreneurs in the construction sector. We're trying to build on that. but also the operational problems that they have right now. The increase in the material and the cost of materials is so pressing right now that it's very difficult to add more, if you want, futuristic ideas on the agenda of the managers, to be honest. So this is just this overview was just to put things into a very realistic framework, because we do want to see sort of a transformation of the sector in Europe, and we're working hard to achieve it. But actually, we're dealing with very serious day-by-day problems right now, and probably this revolution is going to be slowed down a little bit. Now, coming to building information modeling, some of you may be familiar with building information modeling. Some of you probably work already with building information modeling, and some of you may not know what it is. So this is why I chose to put here a very simple definition of what BIM is. I wanted to take it from Wikipedia because it's more understandable. The more sophisticated definitions that are used in the literature may be a little bit harder to understand if you haven't seen, if you haven't witnessed or been involved in a project using building information modeling. So, in brief, it's a process. It's a process that is supported by various tools. Basically, it's supported by digital platforms, various digital platforms, some of them open source, and also supported by contracts involving. The whole process involves the generation and management of digital representations of physical and functional characteristics of places and objects, basically. So what we do, in building information, when we use building information modeling, we actually model the information, all the information related to the building throughout the entire process, from the architects, from the project to the building, to the management of the asset, within a single platform, which is called common data environment. We have a single common data environment. There can be different software, and there usually are different softwares involved, but everything, all the specialties, all the information gets uploaded and dealt with and managed within this common data environment, where all the specialties meet and create a sort of a digital twin. So instead of, if you are architects, you already use probably AutoCAD or something like this for projects, and maybe you render some of the projects 3D in a three-dimensional way. Well, in building information modeling means that you're gonna really create a 3D rendering of the project with all the attributes for each object that you put there, and then the builder, the constructor team is going to take up the project from there and start adding information in the same model as the life of the project goes on, starting from the foundation structure and everything that goes on there. They're going to add attributes to each and every point in the model, so that at the end the beneficiary can actually see how the work is progressing, what kind of materials are being used there. At the same time, the team can see in real lifetime how the project is progressing, the contractors, the time, the resources, everything is being dealt with in this common data environment. So I have put here some keywords because we can't get into detail. It's not a BIM course. It would be nice, but we don't have time for this. But the important thing is real-time collaboration, a standard that we already have by ISO, which is the standard I've put there. If you want to look up for more details to understand how this process is being standardized, that's the standard you want to study. And up to 7D, the literature talks about 7D, 7 dimensions now. So starting from 3D, from a three-dimensional rendering of the project, of the building, we add the other dimensions, which are the time, the costs of the building, and all the materials throughout the life cycle, like I said, the sustainability issues related to energy efficiency, to quality, and then the management of the building. or the infrastructure throughout its entire life. So it's a real revolution in terms of how we manage the process of creating, of generating the building, of making it real, and then managing that asset, which is maybe the most important aspect of, or maybe the most important benefits are to be seen in the asset management zone, although at this stage, we're not quite there yet. So there's very few places in the world where we went so far, where the industry went as far as to have everything in one place and to actually manage the building or the infrastructure using building information modeling. So we're still building this integration of all the phases of the construction. So these are the advantages. I've already talked about them a little bit. You have the 7 Ds, and you see that the evolution of building information model went slow, started quite a few years ago in USA, by the way, and it evolved so as to comprise all and to bring together all these dimensions, and it still evolves. It keeps evolving, and the software companies that develop the platforms to support all this common data, all this work in the common data environment, continually develop new applications and new ways of refining the way we can model the information and work with the information and capture value from working in a common data environment. The advantages obviously are the complete control of all the construction elements, like I said, throughout the entire life cycle. You have a digital book of the building, basically, and a digital twin of the building. You can get easy reports on materials, on different working categories, real-time overview of the estimated costs. You have them during the construction process, and then the beneficiary can see all the costs that were associated with investment. Real-time collaboration with all members of various teams involved, and that is a very important aspect because you have all the specialties in this common data environment, all the conflicts that can appear in practice, all the errors are being tackled in due time. You can actually avoid a lot of the errors, whether you're an architect, whether you work with installations or I don't know, the structure or any other specialty. You can avoid conflicts, and you can see in real time how you can avoid them and where they could occur. Also, however, if you have particular incidents, you can easily cooperate with the other specialties to find common solutions, to find the best solutions. You can do simulations, of course. And then obviously for the entrepreneurs, for the managers, but also for the beneficiaries for the investors, maybe the most important parts are related to cutting costs and time. And these are crucial from my point of view, at least, and also also quality control. Like I said, quality control is a very important aspect that working in this common data environment improves a lot and allows for a better quality control, if you want. Now, this is just an example, just some captures of screens from the applications within a company that we have in our cluster. We have many such examples because the companies in our cluster, most of them are using building information modeling. This is from a company that works on structures. And you can see here a 3D rendering of a structure that they were building, and all these colors represent various attributes that they need to add on the structure. This is how it looks, if you want an example of how it looks. Now, to have an idea of how BIM, how building information modeling is being adopted in Europe, this is a map of Europe in terms of policy making. So with pink, you have the countries that have open BIM standards and a mandate to use building information modeling. It's very few, as you can see. And blue, you have a BIM mandate for public construction and active BIM programs and goals set for future mandate. So half of Europe, as you can see, is actively imposing the use of building information modeling, at least for publicly funded buildings or large infrastructures, and that is already a rule in these countries. But as you can see, the gray area, which is the Central Eastern Europe, is, as you can see, very far away. And we're struggling with this in Romania as well. We're trying to get to the point where we actually have a strategy, and we try to get to the point where at least public buildings are being built using building information modeling. But surprisingly enough, the pressure comes from the private sector rather than the public institutions. So yeah, that's an anomaly in this part of the world, but that's the way it is.